Hello, in this video I'm going to explain the key to algebraic math and science. The key to algebraic math and science are the 5 steps below right here. First is to identify. In most equations in science we have several variables. For example, v is equal to x over t, or the change in distance over the change in time, which clearly we have 3 variables. So we can identify this equation by seeing that we know what variables there are in this equation, and we understand each variable. And we can identify a similar example, which is right here, such as anytime we have 3 variables, we can usually relate them to homework we've done or similar problems we've done before, or honestly what I can do if I don't know an equation is I just wiki it or Google it or whatever you want to call it, look it up in your textbook to find an example similar to it so then I could solve it. So I have now identified this equation, and I can identify each variable: v, velocity, change in x is the change in distance, so I'll just call that distance. And the change in time is time. And then I could give these guys units too, identify as much as I can. So I'm going to use meters per second. It could be feet per second or some distance per second. And distance will be, in this case, it would be meters, and in this case it would be seconds. So clearly I can have meters per second, and that gives me meters per second. So now I've identified the different variables and their units, and in my textbook I should find a similar example so I understand how to do these, and then I organize them. So let's say I have a distance of 5 and a time of 5. Okay, so I have 5 meters in 5 seconds. Alright, so now I don't need to really organize this equation to solve it. I have v is equal to 5 meters over 5 seconds, which is equal to 1 meter per second. And that would be inputting it after I organized, which I can then solve. So I'll choose a more complex one to solve and give a little bit of a better explanation. And what I have here is, what I'll get now is I'll set up the change in x is equal to velocity times the change of time plus 1/2 acceleration times the change of time squared. Okay, now this equation is a little bit more complex, and if I identify each of the variables I have the change in distance, the velocity, the change in time, and then the acceleration. Okay, I have 4 variables in this one. So now if I say I have a ball I threw down at some velocity, I have to identify what I'm trying to solve. So let's say I threw, there's a little cliff here, and I threw a ball downwards with some velocity v. So now, and I know how far it's fallen down, and I am trying to calculate the acceleration of the ball. Okay, so now what I have to do is I have to set up this equation so I have acceleration on this side. So one thing you have to understand about algebra is you have this change of distance, and each of these are considered a single term. So when we're trying to organize this equation, I can then minus this term off from this term, because I move it over to the other side, and that'll equal 1/2, and then I'll put what the variable I'm trying to solve for in orange, and then I have change in t squared. Now what I could then do is divide 1/2 change in t squared on both sides. So what I have is this acceleration, whoops, I should draw that in orange, is going to be equal to this change in x minus velocity, change in t, and then divided by 1/2 change in t squared. And that'll tell you your acceleration. Now what's interesting about this is that every single time I should be able to find an example similar to this in my textbook, so I should be able to know if I am doing this at least in the correct way, and I am organizing it essentially the same. I am always going to try to put a variable on a side which is not connected to the other side. I should put all my variables that I know on one side and all the variables I don't know on the other side. That way I can plug in the variables I know and obtain this A. Now the next step would be for me to input my values for this x, v, change in t, and whatnot. So what I can do is I can just say, in this example, x is equal to 1 meter, v is equal to 5 meters per second, and t is equal to 1 second. So I'm going to solve it over here. I just plug it in. I have 1 meter minus 5 meters per second times 1 second, which then cancel off these guys, divided by 1/2 1 second squared, which gives me seconds squared, and the top part is units. The top units are going to be meters, and this bottom unit is going to be seconds squared, which give me meters per second squared. So we have identified that these units are going to be the units for acceleration, which you can look in your textbook to find an example of. And essentially now all I have to do is plug that in, and that gives me -4 meters divided by 1/2 seconds squared, which you can plug in your calculator or do the algebra. This 2 is multiplied to this 4, and we get -8 meters per second squared, which would make sense since, if you see one of my other videos, velocity is going downwards, which should be negative, or negative acceleration in this case, because it's going down away from the upwards, the normal. Essentially my point is now I solved it by just inputting my different variables in, my different variable values, and that gives me a very simple answer. This works for virtually all math-based algebraic algebra, such as chemistry, physics, and whatnot. And all you have to do is follow these 5 steps. Identify, find an example to see kind of how the equation's done. Organize it properly, which essentially organize into these separate groupings of numbers, which can't be broken out easily. And then move everything to one side, so organize it, and then plug in the input right here, and then you just solve it by using your calculator or solving it by hand, and that should give you the variable which you did not know. It's fairly simple, and this is not a very complex video, but for some people this helps if you don't have a very strong algebraic background. Thank you.